Welcome to qnawire.
So this problem is quite simple in my opinion, but there's a lot of approximation in the graph. So um, there's a margin for error and variation of answers depending on what it looks like to you. But for the first part, we have well, the general idea of this is we want to find the average acceleration, and we know average acceleration a, or I'll call a bar, is delta v over delta t. That's just the large scale approximation without using the limits and derivatives and stuff like that. And so for the first part, we're looking at second gear. And so delta V, I'm going to go from, to me it looks like 24 meters per second. And the bottom looks about 14. And for the time change, I'm going to go from 8 seconds at the end to 4 seconds. And remember, we're going from the end point minus the start point. And so for everything in this problem, since we're increasing, everything's going to be positive since the end point is greater than the initial. And this is A. So this is going to be 10 over 4, which is 2.5 meters per second squared. Next part, we're looking at fourth gear, and again, I'll just approximate about 44 at the end and 37 at the beginning for the velocity. And the time is, looks a little more than 25. I'm going to say 27 minus 16. It looks a little closer to 15 than the 27 does. And that's going to be 7 over 11, which is about 0.6 meters per second squared. And now the last part, we just want to find the average acceleration through the first 4 gears. And so the endpoint is going to be the same as we did here for just the fourth gear. And the start point is at 0. And the start time is 0. And so this is 44 over 27, which is about 1.6 meters per second squared.